Ever wonder how humans really make sense of the world? Not just seeing a ball roll, but knowing it'll bounce, slow down, or maybe even knock over a tower. That's the power of a world model, an internal mental map of how things work. But here's the twist. Researchers just tested if AI models like GPT-4o or Gemini have similar internal world models. And the results? Surprising. So what's a world model? Think of it like your brain's cheat sheet for reality. When you see a car turning left, you predict it'll swerve right, because you've simulated that outcome mentally. But can AI do the same? The team behind this study built a massive test called WM-ABench, throwing 15 top AI models into 23 different simulated worlds to see if they could perceive and predict like humans. Let's break it down. Their framework splits world modeling into two stages, perception and prediction. First, perception, how AI sees the world. They tested 5 core dimensions. Space and time. Can the model tell if an object is front or back, before or after? Motion. Does it grasp speed, direction, or trajectories? Quantity. Can it compare more versus less, or twice as much? Vision. Beyond just recognizing shapes, can it decode textures, colors, or edges? But here's the kicker. Even in these basics, the models struggled. One experiment showed they'd mistakenly assume blue objects move faster than green ones, like a toddler mixing up colors in physics. Then comes the prediction stage. Can the AI simulate what happens next? They tested 3 key skills. 1. Mechanistic simulation, like predicting how a ball bounces off a wall using physics. 2. Transitive inference, linking steps like if A hits B and B hits C, what happens to C. 3. Compositional reasoning, combining multiple rules, like 2 balls hitting a third from different angles. And the results? Yikes. Despite excelling in some visual tasks, the models often performed near randomly when asked to predict motion trajectories or understand cause and effect. One model even thought a cylinder was the answer to a shape question, when the correct answer was a sphere. So what does this mean? These AI models are good at recognizing patterns, but they lack the deep, intuitive grasp of how the physical world works. They don't understand that a blue car doesn't inherently go faster than a red one. They're like a robot trying to play soccer by memorizing rules, not feeling the game. This study isn't just a tech report, it's a wake-up call. For AI to truly mimic human intelligence, it needs more than data, it needs common sense. And that means building better world models. So next time you see an AI guessing the answer, remember, it's not just about pattern recognition. It's about simulating the world, something humans do effortlessly, but machines are still learning. Imagine training a self-driving car without ever touching the road. That's exactly what researchers did here, using a virtual world to teach machines how to see, navigate, and make decisions. Let's break down how they did it and what it means for AI. The researchers used a system called Habitat 2, which creates hyper-realistic virtual spaces. Think of it as a digital twin of a home or city. Here's the magic. The AI doesn't just memorize these environments. It learns to interpret them. For example, it practices rearranging furniture, avoiding obstacles, or even predicting where a ball will roll. This is done through a dual-stage model. First, the AI builds a mental map of its surroundings, perception, then uses that map to plan actions and anticipate outcomes, prediction. But here's the twist. These simulations aren't perfect. They're designed to challenge the AI with unpredictable scenarios. Imagine a robot trying to navigate a room where objects are randomly placed, lighting changes, or physics behave oddly. This forces the AI to adapt, just like humans do when we walk into a new room. The goal? To create systems that don't just follow rules but understand them. This research builds on decades of work in both AI and cognitive science. Think of it as a bridge between how humans learn, through observation and trial and error, and how machines can now mimic that process. For instance, studies on object permanence in babies or mental mapping in animals show that understanding the world is about more than just data. It's about simulation. And now AI is catching up. The implications? Smarter robots that can handle complex tasks, from cleaning your house to assisting in disaster zones. But beyond robotics, this work is reshaping how we think about intelligence itself. If a machine can learn to predict the future in a virtual world, what's next? Maybe we're not just building tools, we're building a new kind of mind. So the next time you see a robot doing something impressive, remember, it might have learned in a world that doesn't exist. And that's the power of simulation. Thanks for watching. If you want to see how AI learns to think, hit subscribe and let me know what you'd like to explore next. Until then, stay curious.